In this video, we are going to look at logistic growth models again. This is making assumptions that we grab data, and there is a lot of spreadsheets like Excel and other software like R that can take your actual data and turn it into a regression, a linear regression, or an exponential. We're not going to focus on that in here. What we're going to do is look at our logistic growth model. And here's my equation. And if I want to know how many fish are in the lake initially, that is asking me to do f of 0. So this is going to be the 1001 plus 9.9 e to the 0, because negative 0.6 multiplied by 0 is e to the 0. We happen to know that e to the 0 is 1. So what I really need to do is take 1000 and divide by 1 plus 9.9, so 10.9. And I end up with 91.7 and some change. We're going to round up because it's live things. So we're going to assume that we started out with 92 fish. How long will it take to get to 900 fish? Well, we do the 900 is equal to the 1000, 1 plus 9.9 e to the negative 0.6 t. We're solving for t. So I'm going to multiply both sides by this, and then I'm going to divide both sides by this 900. So I'm going to end up with 1 plus 9.9 e to the negative 0.6 t is equal to the 1000 divided by the 900. So I'm going to have 9.9 e to the negative 0.6 t. Now this is 10 over 9, so in other words 1 1/9, so 1 and 1/9. I'm going to subtract this 1 from both sides, and so I'm going to end up with just 1/9, because if I have 1 and 1/9 and I subtract off 1, I'm going to just have 1/9 remaining. Now I'm going to take both sides and divide by 9.9, so I have 1/9, and it gets divided by 9.9, and I'm going to have e to the negative 0.6 t is equal to 0.112233445566. I'm just going to go that far. And of course, as we know, we're going to take the natural log of both sides. And when we take the natural log of this side, I'm just going to get negative 0.6 t. I have the natural log of 0.11223344, etc., etc., etc. Oh, there's a 0 right there. There is a 0.0. So this is a 0.0. So there is a 0 between the 1 and the decimal place. And so now I'm going to take the natural log of both sides. I'm going to take the natural log of that number. And then I'm going to divide by the negative 0.6. And I end up with t is equal to 7.482. And if this is time is in months, then it's going to be 7.48 months. If time is in years, then it's going to be 7.48 years. Now, suppose that you have done this experiment and you have taken the data and wrote it all down, and now what you're trying to do is you start out with 1 unit and you let them grow to the environment. So it is a stable population of 500 units. This 500 units is A. This is 500 units. You model the size of your population with a logistic growth curve. Accordingly, the size of your population you chose after X hours is given by this. So what is all of these values? Well, we know that it's going to stabilize at 500, or approximately 500, and so we're going to get A is equal to the 500. Okay, cool. What else do we know? Well, the initial population, well, this A is not to be mixed up with that A up there. The initial population was 1 unit. So I'm going to say 1 unit is equal to the 500, 1 plus B, e to the 0. So what I'm going to get is that I'm going to have 1 plus b is equal to 500. So b is equal to 499. So to answer this question down here, we found the a of being 500. We have found the b to be 499. Now we have to find the r. Well, how are we going to find the r? Well, where we are now is we have f of x is equal to the 500, 1 plus our b, which is 499, e raised to the rx. Now it says that their population doubles every 3 hours. Well, so t is equal to the natural log of 2 over r. Now t, it's the fact that it's 3 hours, so r has to be the natural log of 2 over 3. That is the fact that it doubles every 3 hours. There's that doubles every 3 hours. And so for my r, I'm going to get, let me see, I'm going to take the natural log of 2, divide that answer by 3, and I'm going to end up with an r as being the 0.23105. Now, so there's my r value. Now remember that this has to be 0.5. If we look at this, it needs to be a negative here, so this should be a negative r, so negative r is equal to that. So r is equal to negative 0.23105. So my equation now that I have the appropriate r value, so I'm going to replace that. So I have negative 0.23105 x. Now if I want to know how much it's going to change after 24 hours, I'm going to do f of 24, and also for 48 hours, f of 48. I'm going to put those two numbers into my logistic growth, and for after 24 hours, I'm going to have 171.3 each, so I'm going to put 172, and after 48 hours, I have 496.3, so I'm going to put in 497. Assuming, of course, that we are talking about live things, we always round up. And that's it. So if you want to explore the data, fitting it to an actual exponential growth or an exponential function, then you're going to want to probably take a statistics class that goes beyond just the introductory statistics class that covers those kind of model for the data fitting, or take a data science class. Those also go through that. Other than that, that's it for this video, and we'll see you in class.